On September 12, 2025, the sky handed astronomers a puzzle, a streak so long it could span 5 full moons, and another visitor arriving from the opposite side of the heavens. Two objects, one corridor, one question that will not leave us alone. Why now? The mainstream view at first was tidy. Telescopes caught a bright new comet. Satellites and ground cameras confirmed it. Catalogs updated. It was labeled C 2025 R2 Swan and filed away with thousands of other long-period visitors. On the same chart, astronomers kept tracking 3I Atlas, an odd interstellar interloper already under study. Two comets, both extraordinary, both real, simple, plausible, safe. But facts broke that comfort. Swan appeared on the SOHO spacecraft's on Swan instrument on September 12. 2 days later, an Australian observer, Michael Matiaso, photographed a tail so long it threatened to spill out of the frame. Swan's tail measured roughly 2.5 degrees across the sky. That's about 5 moon widths. It was bright enough for backyard telescopes to pick up. People with binoculars could see it if they knew where to look. Atlas was stranger in different ways. Spectra showed a nucleus dominated by nickel with almost no iron. Its coma pumped carbon dioxide lines far stronger than water. And then the motion. Stepwise accelerations, sudden changes in tail color, brightening pulses on precise dates. The tail did not drift smoothly like a dying ember. It jerked. It pulsed. Some teams called those pulses Delta 5 accelerations. Others called them thrust-like. Independent observers from amateur arrays to professional trackers logged matching spikes. The data didn't line up with ordinary comet physics. If you draw their incoming paths on a star map, the geometry feels uncanny. Swan came from Aquarius, Atlas came from Sagittarius, nearly from the direction of the Milky Way's core. Their vectors are separated by more than a quarter of the sky, yet both objects were set to reach perihelion, their closest approach to the sun, in the same 10-day window in October. Swan's perihelion was calculated near October 20th at roughly 150 million kilometers from the sun. Atlas skimmed closer around October 17th at about 203 million kilometers. On a cosmic scale, those distances are neighbors. On human terms, they overlap in a way that is hard to dismiss. And then there was the blackout. From about October 8th to the 18th, the sun's glare blinds many Earth-based observatories. Both objects would slip behind the sun at almost the same time. That critical window, the moment when any dramatic behavior would be most visible, fell into a period when professional telescopes were effectively blocked. Some teams report internal directives limiting imaging and delaying data release. Meanwhile, grassroots networks of backyard observers and small observatories rallied to keep the sky under watch. Bill Gray and others organized distributed tracking. Amateur radio dishes and open-source software became the alternate eyes. So how do we interpret the measurements? The mainstream line stays cautious. Natural explanations still explain much. Odd composition, extreme sublimation, and rare orbital histories can combine to produce unexpected signals. Long-period comets come in strange flavors. Calibration errors can masquerade as anomalies. Peer review can and should weed out false positives. That is the steady voice of science. But some researchers suggest a different reading. Avi Lobo and his collaborators argued that Atlas behaved like a powered object. They reported abrupt accelerations that matched shifts in tail color and composition. The tail's CO2 dominance and the stepwise timing of brightening looked to some eyes like controlled burns rather than chaotic outgassing. Lobo called the phenomenon thrust mix modulation. He compared one object to a scout, fast, nimble, and instrumented. He compared the other to a fortress, slower, armored, and massively powered. The energy estimates are impossible to ignore. If Atlas's maneuvers are real, the implied internal power approaches the order of 10 gigawatts. That is roughly the output of 10 large nuclear plants. Swan, by contrast, carries claims of something far larger. Reflectance data and spectroscopy hint at a metallic core. Observers reported a silvery halo, a persistent plasma envelope wrapping the nucleus. Some analysis suggested a plasma drive, exhaust of nickel and cobalt ions, and tiny rhythmic thrusts recorded as micropulses in the tail. Teams estimated Swan's core power in the range of 10,000 gigawatts by some calculations, a number that boggles every engineering chart we know. Imagine a flashlight and an aircraft carrier. That is how Atlas and Swan were described by several researchers. Atlas the scout, lean and precise. Swan the fortress, enormous and heavily shielded. The contrast forced a new language in the labs that week. Scout, fortress, patrol, audit. These are not neutral metaphors. They carry intent. If Swan were truly a machine on a 22,554-year cycle, the implications multiply. Orbital analysis from multiple centers suggested Swan might be on a bound path, a recurring visitor with a period that stretches beyond recorded human history. 22,000 years is a number that brushes the end of the last ice age. It is the depth of time when humans built new structures and tracked the heavens in new ways. Some writers pointed to sites like Göbekli Tepe and the Great Pyramid and asked a daring question. Could ancient builders have recorded or remembered a periodic sky event? Mainstream archaeologists push back hard. Patterns can be seductive, and matching monuments to orbital cycles is speculative. speculative, but the resonance remains haunting. Other researchers went further. Avi Lobo and colleagues proposed an audit chain scenario. Human techno-signals from the last century, radio, radar, deliberate messages like the Voyager record, have been leaking into interstellar space. In this view, distant listeners received our broadcast sphere and responded on a schedule. According to this chain model, earlier anomalies like Oumuamua were preliminary scouts. Atlas could be a deployed probe. Swan could be a recovery vessel or a maintenance ship arriving to collect data or to neutralize a malfunctioning unit. The logic is grimly tidy. We broadcast, someone answers. We must be careful here. Extraordinary claims demand extraordinary evidence. Spectral quirks might be artifacts. Tail pulses might turn out to be novel but natural plasma physics. Measurement teams can make mistakes. Yet the convergence of independent signals, nickel-rich spectra, CO2 dominance, rhythmic accelerations, a silvery plasma halo, and overlapping perihelia during a data blackout raises a pattern that many cannot casually dismiss. What would change if even part of this were true? The science would shift fast. Our categories, comet, asteroid, interstellar rock, would need expansion. We would need to invent new vocabulary for engineered small bodies. Planetary defense would acquire a different urgency. Questions about intent would follow. Are these probes benign surveyors, maintenance vessels, or agents in a struggle far larger than our planetary map? The stakes brush up against philosophy. Are we alone, or are we part of an older, quieter traffic lane in the galaxy? The human side of the story is smaller, but no less important. Official silence and data delays fed suspicion. Grassroots observers stepped up where institutions stepped back. Backyard photos and amateur spectroscopy became public records. Small observatories in Spain, Portugal, and elsewhere pooled data. Leaks and encrypted chat rooms carried raw images. The internet filled the vacuum with speculation, expertise, and sometimes misinformation. The tension between open science and institutional caution became a storyline of its own. There is a moral here about observation. Our planet's telescopic net is powerful but imperfect. A vast object can slip into the inner system and, for a moment, render us blind because geometry and glare conspire. The blackout window around the sun during perihelion is a stark reminder. We must build redundancy, protect open archives, and trust distributed observers. The sky is a global commons. We do not get to choose who watches it. So where does this leave us? We keep watching. We parse spectra. We recheck calibrations. We model plasma behavior. We run orbital reconstructions. We argue in journals and in chat rooms. Some teams lean harder into natural explanations. Others prepare papers that open the door to engineered hypotheses. Skepticism and wonder live together in the same lab. For now, the most honest sentence is short. We do not know. We have a suite of anomalies that refuse comfortable explanation. We have two extraordinary objects heading through the same corridor near the sun at almost the same time. One fits a hyperbolic path, a possible one-time visitor. The other fits a long repeating loop measured in tens of thousands of years. One shows bursts and pulses. The other glows with a silvery shield and enormous estimated power. The timing is a puzzle. The silence around the sun is a risk. When Swan and Atlas finally emerged back into view, the first public signals came from small teams and individual observers. Their shared data will be parsed for months. Some theories will fall away, new surprises will appear. Either way, this moment will change how we prepare for the unexpected in the sky. So ask yourself this before we go. If the sky is not merely a field of rocks and ice, but a highway of devices with purposes we have not yet learned to read, what does that mean for how we look up? Whether these visitors are natural or engineered, they force us to build better nets and to think more broadly about our place in time. What will the next pass reveal? Will the silence be broken by a clear signal, a deliberate maneuver, or a mundane explanation that closes the case? Or will the sky keep its secret a little longer, teasing us with evidence that demands patience, rigor, and humility? We will come back to this story. For now, keep your telescope ready, your mind open, and remember, when the heavens change, our questions change with them.